Question 1. Find the surface area of this cube. This is a formula type question, so we'll look to put the formula for this particular surface area on the top line. Then on the second line we'll substitute any numbers we have into that formula and we'll calculate our answer. Lastly, we'll just check our units that they are appropriate. Surface area of a cube has a formula of s squared for one of the faces. So the area of one face of a cube is s times s, whatever that side length is. And so a cube has 6 equal faces. So we build up the formula that way. The surface area of a cube in the end is 6 times s squared, with s standing for the side length. In this case, we have a side length of 7, so we'll insert that underneath or below the s there in the formula, and we'll calculate our answer to be 297 centimeters squared. We started off with centimeters as the side length, but area, when we're working with area, we have to use square units, and in this case it's square centimeters. So final answer, 294 centimeters squared. Question 2. Find the surface area of this prism. Once again, this is a formula question. The formula we'll put on the first line. Underneath that we'll substitute all our numbers, we'll calculate our answer, and we'll check our units. So quite a few sections to this surface area. We have 2 triangles and we have 3 rectangles that make up the surface of this triangular prism. So the triangle area, we have half the base times the height, half the base, which is 8, times the perpendicular height, which is 6. Now we do have 2 of them, so we'll multiply that by 2, and that'll be the triangle sections. Final answer for the triangle sections is 48. Now we'll have a look at the rectangular area for the floor. You can see that the floor is made up of 8 times 12 or 12 times 8, doesn't matter what order you put them in. So 96 square centimeters for the floor area. And what else we got? We've got a rectangle area that makes the left wall. So you can see that is 6 times 12 for the area, the dimensions of that left-hand wall, the vertical wall in the triangular prism. So we've got 72 for that section. And the one we haven't done yet is the slope, the rectangular area of the slope there. You can see that is going to be 10. Now, what we've done there, we haven't got the 10 there given to us, but we know it's 10 by having a 6 and an 8 on that triangle. It's a right angle triangle, and 6, 8 and 10 is what we'd call a Pythagorean triad or Pythagorean triple. So that's something that you might have to do if you wanted to double check that. Run Pythagoras through with x being the hypotenuse and 6 and 8 being your shorter sides there. You'll discover that that's 10 centimeters for the hypotenuse there. So it'll be 10 by 12 for that sloping rectangle, making up 120. Okay, when we add all that up, we have a total surface area for this triangular prism of 336 centimeters squared. We started off with centimeters, which were the lengths, but when we are using area, we use centimeters squared. So tricky one there. In the middle of it there, we had to use Pythagoras to find the length of the hypotenuse on the triangle, which then gave us one of the sides of our slopey rectangle. So breaking it up carefully is important. Acknowledging that we have 2 triangle areas is important, and labeling what each section of our working is important as well, just to keep clear in our minds where we're up to, and so that we don't do some section twice and miss whole other sections. We have to be very organized in our setting out. Question 3. Find the surface area of this cylinder to 1 decimal place. formula question. We'll substitute all the numbers in, we'll calculate our answer, and we'll double check our units. Okay, the surface area of a cylinder formula is made up of 2 pi r squared, that's 2 of the circle sections, and the flat surface or the curved surface that goes around the middle is made up of 2 pi rh. So the next line down, we'll look to put all our numbers in. We've got for the circles a radius of 7, so that goes underneath the r section there. So we've got 2 pi 7 squared, and then we've got 2 pi times 7 times 14. Now that 7 was the radius again, and the h is 14, the height there. So those numbers just go in the right spots in the formula, or directly underneath anyway. And we can do a final calculation there of 923.6 centimeters squared. The question asks for 1 decimal place. We started off with centimeters, but we're finding an area, so we need square centimeters for our units. Question 4. Find the surface area of this rectangular prism. It's a formula question. We'll substitute all the numbers in, we'll calculate our answer, and we'll check our units. The formula for the surface area of a rectangular prism is we're finding really the area of each face, and the surface area of the floor and the roof is made up of 10 times 22 there. And we do have, because we have it on the floor and the roof, we'll multiply that by 2. So we've got the flat surfaces sorted out there. Alright, we then have 14 times 22 for the front wall. And we've also got one of those on the back wall too, so we'll times that by 2. 14 times 22 times 2. Then the ones we still have to do are 10 times 14 for the left and the right walls. And because there's 2 of those, we need to multiply that by 2. So we've got to be careful there and set it out nicely, and labeling each section of our work helps us to keep organized. Final answer there is 1,336, and we'll use millimeters squared because we had millimeters for the lengths of the sides, and when we're working with area we need square units. Now I want you to draw your attention briefly to that section in the middle there. In that middle there, in red, we have 10 times 22, 14 times 22, and 10 times 14. In surface area questions in rectangular prisms, we get in that red section every combination of the 3 numbers, and then each of those combinations get multiplied by 2. So that's like an overall big picture framework to work with there. Question 5. Find the volume of this cylinder to 1 decimal place. It's a formula question. We'll substitute all the numbers straight underneath, we'll calculate our answer, and we'll check our units. Volume formula for a cylinder is pi r squared h, with r being the radius and h being the height. You can see we've got a radius of 9 and a height of 14, so we'll substitute that in straight underneath. We've got pi times 9 squared when we substitute the radius in, times 14 for the height. So we'll stick that into our calculator and we'll get 3,562.6 meters cubed. We were asked to round it off to 1 decimal place. And in volume, we take our meters from our dimensions there. Our radius and our height are in meters, and we have to use cubic units. So that's a double check there. So cubic units for volume. Question 6. Find the volume. For steps for formula solutions, we have the formula on one line, we substitute all the numbers in underneath, we'll calculate our answer, and we'll double check our units. Volume for a rectangular prism here is just length times base times height. Length times breadth times height, sorry. So here we go. Our length is 15, our breadth is 9, and our height is 4. Interestingly enough, because those three items in the formula there are multiplying, it doesn't really matter if you get them in the right order, because order doesn't matter when you're multiplying. 3 times 2 is the same as 2 times 3. So anyway, that's a bit of a safety there. But 15 times 9 times 4 ends up being 540 centimeters cubed. And remember, volume needs cubic units. We started in centimeters, so we need centimeters cubed for our units when we're finding a volume. Question 7. Find the volume of this cone to 2 decimal places. For volume, we'll have a formula. We'll substitute any numbers we have in the question underneath. We'll calculate our answer and check that our units are appropriate. Formula for the volume of a cone is 1/3 pi r squared h. Our radius will be 6 in this diagram, and our perpendicular height will be 14. So we'll look to substitute them in straight underneath here. We've got 1/3 times pi times 6 squared, our radius was 6, and our height is 14, so we'll multiply by 14, just following that formula. We'll type all that in our calculator and get a final answer of 527.79 meters cubed when we round it to 2 decimal places carefully. We had meters in the original question, but for volume we need to use cubic units. Question 8. Find the volume of this pyramid. It's a formula question. We'll write that on line 1. On line 2, we'll substitute any numbers we've got. We'll calculate our answer and check our units. Volume for a pyramid. Volume formula for a pyramid is 1/3 of the length times the breadth times the height. So our numbers here, we've got a length of 10, got a breadth of 6 for the base there, and a perpendicular height of 8. So those numbers just go in underneath, and we'll do a calculation of 160 meters cubed. So we started off with meters in the dimensions, the lengths around the shape, and for volume we need cubic units, so we'll use meters cubed. Question 9. What is the capacity in milliliters of a cylinder which has a volume of 28.3 centimeters cubed? One centimeter cubed equals 1 milliliter. We'll need to know that capacity fact. 1 centimeter cubed equals 1 milliliter. It's a nice simple relationship, 1-to-1 relationship. However many centimeters cubed we have, that's how many milliliters we have. So we don't have to do any fancy multiplication or division here. It's just 1-to-1. So we've got in the question 28.3 centimeters cubed. So we'll have 28.3 milliliters. So if we have a space of or a volume of 28.3 centimeters to fill up with water or milk or anything like that, we'll have a total capacity of 28.3 milliliters of that substance. So final answer, 28.3 milliliters. Question 10. Find the surface area of this half cylinder, correct to 2 decimal places. We'll have a formula we'll look to have on the top line, and we'll substitute any numbers in straight underneath. We'll calculate our answer and check that our units are appropriate. Okay, for a full cylinder, let's compare to that. The surface area formula for a full cylinder is 2 pi r squared plus 2 pi r h. That's if we had a full cylinder, but we don't. We have a half cylinder. So we need to only take into account half of the circular bits. Matter of fact, you can see that the semicircle on one end and the semicircle that's in behind the shape, that makes up one circle. That's why we have a pi r squared section instead of a 2 pi r squared section. And then the surface, the flat surface around the middle of the cylinder, that's actually on the back left hand side that you can't see there in the diagram. That would normally be 2 pi r h, so we would have half of that in this shape that we've got. So that's a pi r h section. And we must, surface area of this shape includes that rectangle. It's like we've chopped the cylinder in half, but we've created a rectangle on one of the surfaces. So that needs a length times a breadth as well. Now here, our radius of our semicircle, you can see it's going to be 16 for the diameter. So that would mean we'd have 8 for the radius. So we'll have to be careful to substitute 8 in for each of these R sections. So then next line down, the half cylinder, we'll follow that formula for the half cylinder. We'll substitute an 8 in for the radius, like I just got through saying there. And in that second section, we'll have an 8 for the radius, and the height of the cylinder, you've got to be careful with these prisms. Sometimes the height of it is actually how far back it goes. So the height in this case we'll treat as the 17, not the 16. Because you can imagine this shape being put on its end, its circular or semicircular end, the height would be 17. It's the distance between the two half circles in this case. So it's like a prism height, which is sometimes how far back it goes. The length times breadth of the rectangle that's being kind of created, if you can imagine a cylinder being chopped in half, is 16 by 17. So a lot of moving parts there, and we had to be careful that we had the radius and not the diameter there, and we had the correct height. Okay, surface area there, 2,182.09 meters squared. It was to 2 decimal places, so we had to round it off carefully. And we had to use meters squared because we're finding a surface area. Area needs square units. We started off with meters, and we're going to meters squared for our final answer there. So lots happening there. We had to sort of adapt the full cylinder surface area formula to the half cylinder section. We had to actually add a rectangle that's created when you chop something in half there of that shape, and had to be very careful with it.